This is Mrs. O'Neill for AP Chemistry, Chapter 4, Section 5, Concentrations of Solutions. In this section, you'll learn how the amount of a compound dissolved in a given volume of a solution can be expressed as concentration. In other words, molarity. In other words, moles per liter. So water must be tested continually to ensure that the concentrations of those contaminants do not exceed established limits. So you are going to learn how solution concentrations are calculated and why it's important. Got to throw a joke in there every once in a while. So what is molarity? Well, the units for molarity are moles per liter, and we usually say it's moles of the solute, that's the dissolved solid, in liters of solution. Remember, that's the aqueous, that's the solute dissolved in a solvent, right? That's that homogeneous mixture. Give it some thought, pause, and see if you can do this without a calculator. Hopefully you knew to divide moles per liter for each of those situations, and you should have gotten that as your answer. So expressing the concentration of an electrolyte. Now remember that an electrolyte is an ionic compound. So again, at this point, you might want to pause the video and fill in those blanks and then play to hear my words. Another thing I want to remind you is you want to read as you write your notes. You don't want to just be writing down those words. Now that we're getting into information that is somewhat new material or maybe a little bit more difficult material, you want to be writing out those words, but reading the entire statement or reading the entire sentence. So we want to understand that when an ionic compound dissolves, because it's a strong electrolyte, it's going to break apart into ions. That chemical formula is going to separate into those ions, and that's going to be really important. So let's take examples here. We have NaCl. If we look at that NaCl, what's it going to break into? It's going to break into the two ions of Na plus and Cl minus. So if we have 1 molar solution of salt water, how many moles of the Na plus are we going to have? 1, because the coefficients are 1-to-1 ratio. So how much molarity or the concentration of the chloride ion is going to be also 1, because again, the 1-to-1 ratio. But now let's look at sodium sulfate. A little bit different here because you have that 2 subscript. So that tells us now that we have 2 sodium ions for every 1 sodium sulfate compound. So our products would be 2 Na plus and 1 SO4 minus. So now if we start out with 1 molarity of the sodium sulfate salt or ionic compound, we have to multiply that by 2 to get what's the molar concentration of the Na plus, and of course it would just be a 1-to-1 ratio for the sulfate ion. So again, that 2 is going to be really, really important. So interconverting molarity, moles, and volume. So you got 3 things there. As long as you have 2 of them, you can solve for the third. So if you have molarity and moles, you can solve for volume. If you have volume and moles, you can solve for molarity. We also want to be able to treat molarity as a conversion. Just like density, you treat it also as a conversion when you needed to go from a gram unit to a volume unit. The difference is here, though, density can be any gram unit over any volume unit. In other words, I could have grams per milliliter. I could have kilograms per milliliter. I could have grams per hectoliter. Okay, you can have any gram unit to any volume unit. With molarity, it's not the case. Molarity has to have the same, how do I want to say it, like unit conversion. So moles and liters are like the same. So that's like that 1-to-1. So moles per liter is what you're used to seeing. However, for some reason, if they do millimoles, then it must be per milliliter. So hopefully that makes sense to you. So again, density can be any gram and any volume unit together, where the molarity, though, must be the same kind of ratio. So let's do some practice problems. Again, at this point, pause the video, see if you can at least attempt or try Some of this might be review from Chem 1, and then play the video and see if you get the right answers, or again, play and pause as I go through the solutions. So your answer to number 1, you want to know how many grams of NaOH would be needed to make 50 milliliters of a 2.7 molar solution. Well, we got to start with the 50 milliliters. We also want to remember that, again, molarity is moles per liter. So we got to change those milliliters to liters. Now that we're in liters, now we can use the molarity to get from liters, that volume unit, to a mole unit. Again, there's 2 out of the 3. Once we're in the moles, now we can use our formula mass and get to grams. I also strongly suggest doing your mathematics in order. You don't have to do the ones, but it would be 50 divided by 1,000 times 2.7 times 39.998 equals the 5.4 grams of NaOH. So as a chemist, or as a chemistry teacher, when I have to make you solutions that you're using in the chem lab, if I, for whatever reason, needed a 2.7 molarity solution of NaOH and I only needed 50 milliliters of it, I would calculate and figure out that I would need 5.4 grams of the NaOH. And that's going to be really important because we don't want to make solutions we're not going to use. We don't want to waste anything. So how about number 2? Did you attempt this one? It says, what would the concentration be? Well, when I think of concentration, I think of moles per liter. So now I'm going to continue reading the problem and go, I don't have moles, but I do have grams of my substance. Well, that's Mole Island. You're going to go from grams to moles and get your number for the moles of the calcium chloride. Now, you don't have liters, but they did give you 500 milliliters. Well, you can easily change the 500 milliliters to 0.5 liters. Again, do your division, and your answer is 0.486 molarity. So number 3, if you didn't, I'm sorry, let's continue with number 2. I forgot about this one. What is the concentration then of each ion? Well, if we have the concentration of our salt, the next thing we would need is the reaction. So we're going to take the calcium chloride and break it up into 1 calcium plus 2 ion and 2 chloride -1 ions. So if we're starting with the 0.486, you're going to have 0.416 here because you have a 1-to-1 ratio. However, because of that 2 there, we have to multiply the 0.486 times 2 to get the molarity concentration of that chloride ion. So now number 3, if you didn't do it yet, it's exactly like number 2. So go ahead and give it a try, pause the video, and then play to hear the solution. So you should have gotten that for your molarity. And then again, for your concentration of each of the ions, you need that reaction. So make sure that you are separating that ionic compound into the proper ions. Very similar to your double displacement reactions, right? You're separating it apart from a molecular equation to your complete ionic equation. But now we're just really concentrating on one substance. You should have gotten that. So if you start with that, because that's the answer, multiplied by 2 to get the molarity for the iron, and multiplied by 3 to get the molarity for the sulfate ions. So dilution is taking a concentration and lowering it because we're adding water. Now you do want to remember though, the moles always stay the same. However much moles of solute you started with, that's how much moles of solute you end up with even after the dilution. And that should make sense. So the moles stay the same, but the molarity value is going to change because you've added that volume. And you might have seen that M1V1 equals M2V2. You might have seen that before. I just use now concentration versus dilution. It's the same equation. So again, try these practice problems on your own if you can. You're using basically that M1V1 equation. I believe it's also on your reference sheet. And then play to see the solutions. So here's your answer to 1. So again, we're using that M1V1. I plug and chug basically what information I have, and it's basically your x, right? If this is your x, like in algebra, you're just solving for it. and you should get 73.5 milliliters. No need to change the units, right? Molarity cancels out. They're asking for volume. It doesn't specify what unit of volume, so you can just keep it as is. How about number 2? Again, we're using that M1V1. Plugging and chugging, but now you're using molarity, and again, milliliters is going to cancel out and you're left with molarity. Now, if for whatever reason they would have given you, let's say 18.5 liters and 250 milliliters, then you would have had to change one of the units to the other, so they would have canceled out correctly, and you should have gotten that as your answer. So see if you can figure out this answer. Ooh, M1V1 again. Again, you're plugging and chugging. This time, though, it says, how is the molarity changed when the water is added to double its volume? So what did I do? I made up some numbers, very easy numbers, 10 liters to 20 liters. Again, plugged and chugged, find my X, and my X tells me that it went by half of the original. So it went from the 0.5 molarity to the 0.25 molarity. Okay. See you in class for some book work. I thought this was pretty cool. Got to play till the end now, you know what I'm saying? Ah, the end. All right.